All right, let's work on this example. We have a quadratic function, x squared minus 4. And first we want to write f of x in factored form. So we're looking for the zeros of this equation. All right, f of x is x squared minus 4. And you could either use the quadratic equation, or you can note that this factors without too much hassle. X minus 2 and x plus 2. I knew it had to be plus and minus the same thing because I didn't have any b term. I didn't have any linear term. Right. In fact, let's just double check ourselves that this is correct. If we were to multiply this through, you'd end up with an x squared. You'd end up with a minus 2x. But then you'd end up with that plus 2x. So that's why we don't have any middle terms. And then the minus 2 hits the 2, ends up with a minus 4. Yep, so this right here is a good factorization. X minus 2, x plus 2. And because we have the factored form, we can easily tell what's going to make us 0. If I set my function equal to 0, then either the first factor is going to make me 0, or the second factor is going to make me 0. So I've got a 0 over here at 2. I've got a 0 over here at minus 2. And my leading coefficient is positive. It's a 1. So I'm concave up. The only thing we haven't talked about, so we've done the zeros. Let's give ourselves the y-intercept. Where am I going to cross the y-axis? So what is my function value at 0? Right, I'm asking for where do I exist there? This is going to give me a 0 squared minus 4, gives me a minus 4. So that's a pretty decent idea of what the graph looks like, right? I'm not an artist, but at least the zeros and the end behavior are correct along with the y-intercept.